We will talk about the image segmentation and object detection of lunar landscape today. My name is Chen Wu. I will mainly talk about the image segmentation, and Yuan will talk about the object detection using YOLO later. So our main goal is to create a segmentation method such that the given input is a synthetic image of the lunar landscape, and the output is its segmentation consisting of four colors, like four classes, like big rock, small rock, ground, and skies. So the model we are using is FCN 8S in a deep lab version 3 plus, and we use some transfer training method to free some layers and train the rest. So in order to make it train better, we do some normalization and select some good pictures, and also increase the contrast ratio of the inputs. And for the result, we can compare what happens to the FCN 8S and Deep Lab version 3 plus. They have the similar main IOU of training, which means they both did satisfied jobs, but we can see that Deep Lab, by testing on the synthetic images, Deep Lab did a better job to recognize some large rock far away from us, which looks small, but really they're large rocks. And Deep Lab seems to distinguish stones closer to each other better than FCN. But by testing on the real lunar landscape, we can see that actually FCN did a better job. It can recognize these large stones and small stones, but Deep Lab just sometimes gives some background color. So to improve such method, a more realistic synthetic lunar surface might help. So scientists might want to work on it better to create more realistic synthetic lunar landscape. So another way is to do some data augmentation to the synthetic images and make them more like the real lunar landscape. And my talk is over, so next Yuan will talk about the object detection using YOLO.
Hi, my name is Ziyang Yuan, and I'm going to talk about the object detection part of our project. We used YOLO V2 algorithm with 5 anchors to predict the bounding boxes around the large rocks. We started the training with pre-trained backend and performed transfer learning. The learning rate was set to 0.0001 and the optimizer was Adam. We trained with mini batch size of 16 images, using 13 by 13 grid cells. The results looks very reasonable after 10 epochs of training. This synthetic pictures is one of the pictures from the depth set. The average MAP was 63.4%. And this one was the real photo from lunar surface. We can conclude that YOLO V2 is a very good approach to detect rocks in both synthetic and real pictures. To further improve the results, we need to focus on reducing the biases. We could do that by increasing training set size, correcting mislabeled data, or perform image augmentations. Okay, I think that's all for our presentation, and thank you for listening.